Let's now find the total resistance in this figure. So here, if you notice, current enters at this point, and here it splits into two arms, one here and the other on this side. So we have here, we'll call this arm as resistance R1 and here resistance R2. Now this current here flows right through 3.5, it will flow through this, then it will flow to 8.5 and at this point. So I can say that 3.5 ohms and 8.5 ohms are in series because it is the same current that is flowing through all. So my R1 will be equal to 3.5 plus 8.5 and your R1 will be equal to 12 ohms. Now for the next R2, in R2 the current flows here, it flows through 2.5, then it goes out here, it flows through 0.5 and it comes here. So for R2, for the next one, I can say 2.5 ohms and 0.5 ohms are connected in series. Why in series? Because it is the same current that is flowing through both. So my R2 will be 2.5 plus 0.5. So R2 will be 3 ohms. Now if I have to draw the diagram again, here the current enters, here the current leaves. Now in this arm, here we know is 3 ohms, and then we have the other arm here, we know this is 12 ohms. This is my R1 and this is R2. Now R1 and R2 are connected in parallel. So to find this, 1 by R equal to 3 plus 1 by 12. So 1 by R, LCM 12, this is 4 plus 1, that is 5 over 12. So I have R will be 12 by 5 ohms. So this is the resultant of this entire figure. And how do I know that this is in parallel? Because see, at this point here, the current is splitting into two parts. One part on this side, one part on this side. The same current is not flowing through 3 ohms and 12 ohms. Therefore, I say 3 ohms and 12 ohms are connected in parallel, and I use the parallel formula. However, here, if you see 2.5 and 0.5 are connected in series. It's the same current that is flowing through both. And here 3.5 and 8.5 are connected in series. It's the same current that is flowing through both. This is the second diagram. It looks like similar from the first, but is very different. So here the current is entering at this point. Again, it splits into two. Here you have one branch. We will call that as R1, and then we have the other branch here, and we will call it R2. So let us see what is the R1 made up of. Now R1 flows through 8 ohms. It then goes right through, the same current is flowing through 9 ohms. And the same current is again flowing through 7 ohms. So now I can say that the 8 ohms, 9 ohms and 7 ohms are in series. It's the same current flowing through. So my R1 equal to 8 plus 9 plus 7 ohms. So R1 equal to, that is 24 ohms. Now to go for my R2. Now R2 comes here, it flows to this here and then here. So my R2 is only made up of 6 ohms. Let's draw this figure again. So the current came in here and it broke up into two arms. One was the green one here, and then the other was the blue one, and then it went up again here. The green one we know was 6 ohms, and the blue one we calculated as 24 ohms. Now if we look at the green and the blue, we know that 6 ohms and 24 ohms are in parallel. Why parallel? Because at this point the current is splitting into two, one here and one here. The same current is not flowing through both the resistance. So we use the formula 1 by R, 1 by 6 plus 1 by 24. So 1 by R equal to LCM 24. So this becomes into 4 and 1. Here 12 by 5 ohms. Same diagram. However, in this case it was 5 by 24 by 5 ohms.